Hi everybody, Sahil Bora here from C++BetterExplained.com, and today we're going to be talking about the solid principles in object-oriented programming. So with a brief overview of the solid principles in object-oriented programming, the solid principles were pretty much a set of guidelines for writing high-quality, maintainable and scalable software, which was introduced by a person named Robert C. Martin in his 2000 paper called Design Principles and Design Patterns. And these are the solid principles that he's outlined in his paper, which are single responsibility principle, open-close principle, list substitution principle, interface segregation principle, and dependency inverse principle. So I'm going to be giving you a high-level overview of each of these principles in today's video. So let's start with the S one, which is the single responsibility principle. So in simple terms, what the single responsibility principle is that it states that a class defined should only have one reason to change, which effectively means it should only have one responsibility or concern. So when we define a class with the SRP, a class method should only have one reason for it to change, or a class or method should only have a single responsibility. That can be defined as a single responsibility principle. So let's say, for example, an analogy that I can give for you guys is that, let's say we're describing a police officer. Their single responsibility principle is to protect society and people and the public. That is, I guess, their single responsibility principle is to protect and serve the public, which is a high level analogy that I can use to explain the single responsibility principle. Next, we have the open-closed principle. So what this means is that software entities that are developed should be open for extension but closed for modification. So in the C++ programming language, this can be including applying the concept of inheritance and polymorphism in our C++ programs. So on the left here, we've got an example here of applying inheritance here, where we've got these diagrams here where we are implementing the concept of inheritance here for this calculator program that we've defined here. And then also on the right here, we've got a block diagram here where we are applying the concept of polymorphism in C++, particularly in a video game example here, where we have a game and we've got a character, but with the definition of polymorphism, it can be one of many things. So we've got a warrior and a magician and a dragon, and they're all interfacing these character functions here that we've got here. So we've got move, attack, and defend, and all these different characters that I've listed here are able to do all these things which the character class has been defined. Next we have is the list-scoff substitution principle. So what this pretty much means is that objects of a superclass should be replaceable with objects of its subclass. So a high level an analogy to explain this is like if we have Visual Studio 2010 installed, for example, it should be backwards compatible with Visual Studio 2005, and it should be also backwards compatible with also Visual Studio 28, because it's been building up with the different versions throughout the Visual Studio software lifecycle. And as well as on this example here that I've got on the right in this block diagram here, see how we have a bird defined up at the top of the hierarchy. Down the bottom of the hierarchy, we've also got subsectors of the different types of birds. So we've got the duck, we've got the cockatoo, and we've also got the ostrich as well, which can also be as which also can be defined as subversions of a bird in this Liebscomb's substitution principle. Next, we have the interface segregation principle. So what this means is that clients should not be forced to depend on interfaces they don't use. So let's say, for example, we have defined a class that's called iVehicle, and we've got two functions that says that we've got two functions defined that are drive and fly, which are void functions. But then if we try to extend that into if we extend that into different classes, and we're also inheriting the iVehicle class, what's happening here is that we're able to implement the drive function here, but cars currently aren't flying in 2024, so we can't exactly implement the fly function here. So this is violating the ISP principle here, and it's same for here in this example here for the plane class here. So we can obviously implement the fly function here, but we can't implement the drive function here because when planes are flying out in the air, it's not exactly driving in the air. So again, this is violating the ISP principle here in this design here. And then lastly here, we've got the dependency inverse principle. So what this means is that high-level modules should not be depending on low-level modules. Both should be depending on abstractions. So you can think of the abstraction layer as like a middle manager. So the high level module is also going to be interfacing with the abstract layer, and as well as the low level module is also going to be interfacing with the abstract layer as well. So the abstract layer can be defined as a middle manager that works between the two, the high level module and the low level module as well. So this explains the 5 different principles of the solid principles that have been defined for object-oriented programming. So if this video has helped you out a lot in understanding these solid principles and object-oriented programming, hit the like button down below, and don't forget to click on the red button down below to subscribe to the latest videos of the C++ Better Explained YouTube channel. Attention computer science and engineering students. Are you tired of falling asleep in class while your lecturer spills that C++ gobbledygook? My name is Sahil Bora, and I'm the founder and proprietor of the C++ Better Explained website. What I'm offering you guys today is my 87-page book that outlines how to quickly and easily master the fundamentals of the C++ programming language. So if you've been searching around for free C++ tutorials that haven't made any sense at all, or free YouTube videos that have made you want to gouge your eyes out, my book will put all that rest today, because my book is written in a straightforward and direct manner that will get you understanding the fundamentals of the C++ language in a matter of days, using my learning tools such as Analogies for Dummies, Logic Made Easy, and simple code diagrams that makes learning the C++ language brain dead easy and super fast. The book is $19, so click on the orange button below and pick up your copy today. You will not regret this at all.